Today we're going to be talking about how to solve a system of equations by elimination. Elimination because we want to eliminate one of our variables to start with, so it makes it easy to solve for the other variable. So before, what we were doing, we were given problems where we could easily identify what our opposites were, so we can eliminate them by adding down. But if you look at our problem here, we have 3x plus 8y equals 26 in red, and negative 5x minus 2y equals 2 in green. So the 3x and negative 5x are not opposites. 8y and negative 2y are not opposites. So we need to do something to get them where they're opposite. So you have to look at the x's. Can I pick an equation and multiply something by 3 to get to a positive 5? Or multiply something by negative 5 to get to a negative 3? No. What if I multiplied something by 8 to get to a 2? Or multiply something by negative 2 to get to negative 8? This last option is possible. If I multiply this negative 2 by 4, I will get a negative 8. That's what we want to do. So we have to do that to the entire equation. So this is our first step, finding the opposites of a variable. So I'm going to multiply this whole equation by 4. The top equation, I'm not going to touch. I'm going to rewrite that. I still have 3x plus 8y equals 26. My new equation, though, is 4 times negative 5 is negative 20x. 4 times negative 2y is minus 8y. And 4 times 2 equals 8. There's my new equations. This is the exact same thing, except I multiplied everything by 4. Now, I do have opposites. Positive 8y, negative 8y. I can now add down. 3 and negative 20x is negative 17x. These cancel out. And 26 plus 8 equals 34. Now this is easy to solve. Divide both sides by negative 17. And we get an answer of x equaling negative 2. So that's part of my answer, is an ordered pair. Still need to find y. So I'm going to pick one of these equations. You know me, I like positive numbers, so I'm going to use this red equation here. And I'm plugging the negative 2 in for x. So I have 3. I'm putting this negative 2, substituting in for the x. 3 times negative 2 is negative 6. Add my opposite. And divide. Substituted, multiplied through. Added my opposite to both sides. Divided by both sides, I got y equals 4. So my solution is negative 2, positive 4. Everything's the same as what we've been doing, except I had to find an equation to multiply by in order to find opposites. So we're going to do one more. So my red equation is negative 3x plus 4y equals negative 7. My green equation, negative 6x plus 11y equals negative 8. So, I'm going to start by looking at my x's. Is there a number I can multiply by either the 3 or the 6 to get the other one? Well, if I multiply the top one by 2, I can get to a 6. But that will leave me with two negative numbers. If this is -6 and -6, they are not opposites. So instead of just multiplying by 2 to everything, I'm going to multiply by a -2 to everything. Now, my new equation is positive 6x minus 8y equals 14. Again, I doubled everything and I changed the sign because I multiplied by a negative number. Bottom equation doesn't have to change. I have my opposites. From here, we can add down. These x's cancel. Negative 8y plus 11y is 3y. 14 and negative 8 is 6. Divide by 3. And we get y equals 2. Put it in the y spot. So now, again, I have negatives in both equations. We can pick, but you know what, the top equation is smaller numbers. So I'm going to use this one instead. So I have negative 3x plus 4 times 2 equals negative 7. Four plus 2 is 8. 4 times 2 is 8. Add opposites. End up with negative 3x equals negative 15. And when we divide by negative 3 to both sides, I get x equals 5. So my answer there is 5, 2. The only difference is if we do not have opposites, we need to multiply by an equation to get an opposite. From there on out, it's the exact same process. Hopefully this helps, and good luck on your assignment.